Back here on the little Jeep fleet van project, I'm working on setting up to trim the frame for a notch. Now I want this thing, it is going to be on air ride, and I want the tires tucked up in the fender well. I've already measured out while I had the axle here that will allow the tire to come up inside here. Now this is going to be a little bit strange. I've decided that I want to do keep the solid beam axle. So I'm going to keep the original steering box. It's really tight and in good shape. It's a Ross box. I would like to kind of keep an old school front end setup on it, and I've been wanting to mess with something like this on an old vehicle, and what better than a van that I really don't care how fast it'll go around the track on. So what I've decided to do is going to notch the frame so I can get it low enough. That's my biggest priority here, is A, that it drives better. I need more caster angle in this thing. Manual steering vehicles, older vehicles, do not have a lot of caster. Now, caster angle in suspension does a couple things. It gives you a return to center. So when you let go of the wheel, the steering wheel wants to come back and your wheels want to return straight. It also increases straight line stability. So when you're going down the highway, it's less likely to wander around. It's less likely to grab irregularities in the pavement. And that's what we're looking for, is more stability. This thing is tall and has a short wheelbase, and it doesn't weigh very much. So it's going to be a kite on the road with any kind of wind. So I'm probably going to put quite a bit of caster in this thing, and then I'm going to do a parallel 4-link, which will give me adjustability to kind of fine tune that. So a lot of the early street rods are 4-link with a beam axle. It's kind of a classic look, and really the main reason I'm doing this is just because I wanted to do something different. I've done so many Mustang 2s. I just don't care to do another one right now for this particular application. And I am keeping the manual steering box, but I'm going to do an electric assist system like a lot of the modern cars have. The one I'm going to use is from a company called ePass. I believe that's how you say it. And it's for an early Jeep, like a Willys Jeep, but I've used them on other cars, builds in the past, and they work really well. So I will be, in this situation, this box, the steering column, you can see we're under the van, that's the steering wheel up there. It actually runs through the dash and goes straight into the steering box. So what I'm going to be doing, cutting the steering column and right here, so we have a section of shaft sticking out. I will then modify the shaft to accept either a double D or a weld-on U-joint to go here. And that's going to let me do a couple of things. The steering wheel, the way this is set up, they didn't have any room, and because the wheel is attached to the column, the wheel sits at a goofy angle. So once I do this, because I'll have an intermediate shaft with 2 U-joints, I can actually move the steering column to better fit me as a driver, make it more comfortable, which will be really nice, and straighten it out. The other thing is it'll have a motor that sits up under the dash. It's basically a self-contained system. There's no power steering lines, no power steering pump. It's all electric. And I will have a small knob on the dash where I can speed up or slow down the amount of assist on that steering. So I don't need a ton of assist on this thing just because the front end's going to be pretty light, kind of a small tire. But it's nice to have some assist, you know, in a parking lot or something like that, and it just gives a little bit better feel. So I am going to do that electric assist setup with this box. And I'm going to keep a standard crossover steering setup on this, kind of like what would be on a solid axle 4-wheel drive. So that'll keep my steering angles and my bump steer under control. And like I said, probably going to go with maybe 1/8 of an inch, 1/16 to 1/8 of an inch of toe in, so the 2 front tires are going to be pointing towards each other in the front, And then your caster angle, if you picture my hand as the C of the axle, negative caster is actually backwards. Negative is forward, positive caster is backwards, and we're going to go for positive caster, so we want the knuckle to be tipped back a little bit. And what that does is when you turn, it's forcing the tire into the ground and basically is pushing up on the car, so the weight of the vehicle is forcing that tire to return straight. So the tire wants to stay straight, it wants to track straight, and it's actually more effort from gravity to be turned than it is to stay straight. So that's what gives you your stability. So anyway, this is where the old bump stop was. This is, I've confirmed, the center point of my axle. I have marked this. I drilled a hole here. I was going to use a saw on this, and now I've decided, now that I got my plasma cutter fixed, that I'm going to go ahead and just freehand plasma this on my lines, and then we will fit the new boxing piece that I've made to go in there. So let's get this cut out. So now I've got my notch cut out, just kind of roughed out. I'll finalize it by hand. This is just roughed with the plasma. Now you'll see this frame is boxed. So how do you get the arc in the same place on the other side? Now ideally, if I had enough time, I would just build a simple guide that slides up over the frame. You cut both sides and you're done. But let's face it, I'm not going to do that. So what I do to make my notch in the exact same place on the other side, so you don't accidentally cut too far one way or the other on the mirror side, is I just take a drill, like a 3/16 drill bit. I go in my corners, put my drill bit right in the corner, drill a hole through, drill a hole through here, drill a hole through on my center line, and then on the other side you'll have 3 holes to put your piece up and run your new line, and it'll line up absolutely perfectly. Pretty darn close. I like to leave a little bit of a gap for more penetration. I still have to fine tune the edges of this, but we're getting pretty close. So I'll get this dialed in and then we'll get it welded in. Alright, I am still trying to dial in this Everlast inverter welder, but I am used to the old school Miller stuff. But I'm just working on this, dialing it in. It's doing okay. This is thick to thin, so 1/4 inch to 1/8 inch. Looks like I'm getting pretty good penetration. I wish I could have done this one in one solid pass, but did it in two. Looks like it's going to do just fine. So the nice thing is, even though I am taking some strength out of the frame rail right here, I'm adding it back in with the strength of that half piece of 1/4 inch pipe. Here's what we are with our notches. I'm going to show you a little trick that I came up with over the years. I always did link suspension on the ground on jack stands. As you get older, you decide you don't want to roll around on the ground as much and get up and down 3 billion times while doing this. So here's what I do. Very simple. Mark holes. Make sure you measure from, points that are the same on both sides of the vehicle. Drill you a couple of holes and run a piece of chain. Now you can set your vehicle at ride height. So once you figure out your ride height on the ground and you know kind of where you want the axle to live at ride height, and you're going to be setting your pinion angle and trying to center everything, you got to limit how many directions that things can move. So what I do, cut a piece of chain that's close to where your ride height is. Make sure you have the same number of links on both sides. Drill a couple holes right here and run a chain under the axle and bolt it up. Now your axle is hanging and you can lift your vehicle up off the ground, and that axle's not going to fall out. It's not bound up on jack stands. You can adjust your pinion angle by turning it with a screw jack or a jack if you're on the ground. You can move it side to side, but once you do move it, it stays in place because chains don't let things move very easily. Also, chains don't stretch, so as long as you get these holes in the same place, it's not moving. So you're not going to get it crooked or side to side off as long as your holes that you drill are in the right place. The other thing is, when you're done with this, if you keep these holes and you keep these pieces of chain, say you have to change a shock or a bag or something, or you want to lift your air ride vehicle off the ground to do work on it later, keep your piece of chain, bolt it back on. You can lift it up and you don't have your vehicle hanging from the shocks. Got to think smarter, not harder. Well, back up under the van, got all 4 notches burned in, and I slid the axle under here on a couple jack stands and dropped her down. So you can see now the axle can live inside the frame when it's fully aired out. And the pumpkin just clears this cross member, barely, about a 1/4 inch. We'll have to do a small drive shaft hoop in the front on that cross member, touching the yoke right now. Just need a little bit more clearance there. I'll either build a new cross member that's a little more clearance, or do a hoop in that cross member, which is basically the same as doing the notches. But yeah, she lives nice and snug under there. And I went ahead and stuck a wheel on it so we can get an idea of what it's going to look like aired out. There you have it. Definitely slammed, and it'll come up probably, let's say about 3.5 inches from there for ride height for driving it, and then it'll drop down when it's parked. But yeah, it definitely changes the whole proportions of this thing. It's looking killer. I'm stoked about this. I'm gonna go ahead and get started on this front suspension. First thing, I'm gonna mark this link bar for the upper part of the 3-link. Now, as you've noticed, we're going towards the front of the vehicle now. So after mocking things up the first time, I realized that a parallel 4-link to the rear will not fit. So this is going to get very interesting. This is kind of going to be an experiment here. I'm going to build a parallel 3-link, but the links are going to pivot off the front. just getting set up to bend this upper link bar so it will clear that factory cross member on the frame. I'm just trying to get the bushing squared up, make sure it's set in the die, and then check the bushing for square to the die so it's not bent crooked. Still crooked, gonna have to loosen it up a little bit. Unfortunately, I stored this thing outside for a while. I need to take some fast etch to it or bead blast it and get it looking cleaned up again. I built this thing years ago. Not fancy, but it gets the job done. Built a lot of cages and bumpers with this old bender.
So that's like,
seems like you need to go up about 3.5 inches.
yeah.
It's been a while since I've seen tube bent.
Right? I got really lucky that I have enough length for the end. Scary.
Always put a mark where the tube starts at the die, so if I have to put it back into the bender, I know exactly where to start my bend again. Just line up that mark.
Oh, that's perfect. End up right there. About 14 inches.
I actually got pretty good like penetration on most of that weld.
Yeah, it looked good.
Most of it's all the way through that frame.
I saw that from the backside. It was all the way through.
Yeah, I'll just weld it from the inside. I'm probably just gonna cut a rectangle plate out and put it on the inside.
What is that going to visit you?
Oh, big ass cockroach beetle.
Is that thing?
Oh my god, looks like a wasp. Let's see.
I have never seen a beetle that's bright freaking orange.
Be careful.
Dude, that thing has some serious pinchers on the front of it.
Yeah.
Get in there.
You're gonna retire inside the tube.
Is that a wasp or?
No, I think it would have flown by now. It kind of looks like it.
It has wings. Get out of here, little buddy. You must have brought that because I've never seen that before. It's camera shy.
He's wanted. Do a Google image search.
For the Beetle?
Yep.
Did you see the flow restriction here?
Don't. No, that's fine.
I would definitely start scratch with stainless.
I agree.
Mandrel, 4-inch dual.
I agree.
And then you could do rear mount turbos. I still love the cherry bombs turned into tips and leaving the sticker on. That cracks me up.
Small town shit.
Hey, it works. I just like that someone took the time to gut a glass pack to put that on there.
It was a farmer.
That does look like something a farmer would do.
No.
I definitely approve.
Jump on him.
Doodle.
Well,
Puppy.
there's some weird.
There's a really weird beetle over there. Go look at it.
Kissing beetle?
It's orange.
Oh, well, looks kind of mean.
Yeah, it's probably like a Bill Gates mechanical bee.
Right?
Yeah.
It's because I've been looking at all those
Beetle.
conspiracy channels.
Master blister beetle.
Oh, does it cause blisters?
That's a blister beetle? Is that in Arizona?
Safety warning: these beetles produce toxic chemical that can cause severe blistering upon skin contact.
Oh, we're definitely
You're
killing.
dead.
See you later, dude.
Let's go. Ew, what came out of that?
That is gross.
It's okay, dude.
Blister material.
Yeah, it's called a master blister beetle.
Ugh.
But you guys bring them in.
No.
The place where I'm rolling around on the ground all the time
Yes, you guys
doesn't
are
need to
bringing
be
it.
sprayed.
You guys are bringing shit in from some abandoned.
That's definitely Justin. I've never brought one of those in.
That came from that.
That's a Utah bug. It came out of the dually.
Living in this truck for a year and a half.
It's been perfectly happy in the dually, and then you decide to cut the dually in half.
Still alive.
Kill it again. I'm sure. Do it. Smash it. Gross.
It's still gonna be live out there for like a week.
Now it's definitely going to give you a blister. It's pissed off now.
Master blister beetle. Dan likes collecting things.
I have no idea what you're talking about.
I guess it's almost straight, huh?
Yeah. Let's straighten
It's
it
just
out.
tipped down.
Well, it's level with whatever surface this is.
Yeah. That's not perfectly straight. I'll true that up because I just cut it with the Sawzall to get rid of those bumpers.
Yeah.
But I can true that up once we make the piece.
Alright, that's gonna be close enough to set on there.
Did you weld the end of your square?
No. Broke it, dropped it.
Oh,
Got one that's broke here,
it
one
looks
that's
like
broke
it's
here.
burnt.
No. No.
I figured there was a story behind that. I think it looks pretty good.
Me too.
That should be good for this. It's just a scrap piece. Look at that. There's our first template for our 4-link mount. I think we can cut that out of our material. Yeah, it's perfect. This is perfect over here. The bottom edge is perfect. This is undersized, which I like because on 3/16 it's going to push it out a little bit too in the bend. That should be good. Let's switch to materials. Alright, we've grouped these two. So we have one for one side that has 2 link mounts. The other side is going to be the bottom link. Kind of see that. Now we're ready to cut our piece of 3/16. There's our finished bracket.
We have a whole mix of nuts.
All kinds of mixed nuts. The only thing we didn't take into consideration was this line is at a downward angle. So when we bend this around, it might be off slightly, but I don't think it'll be enough to hurt anything.
I think it was 90 to that line.
See how the line's at an angle?
Yeah, but I think that frame rail's at an angle.
Once I square the frame, it should be fine. Oh yeah, that's... That's perfect. I can just weld all the way around and good. It's good. That couldn't have been any better. That's badass.
I like it.
I like it too. Yeah, girl, push on with the hammer. Sweet. Got one down here.
Let me,
You good?
Yep.
So, what we have come up with is our 4-link goes forward, or 3-link, I guess, sorry. We're gonna cut some more spacers. This is gonna live right under the, the steering's gonna run in between the 2 links. Upper link curves under, lower link remains straight. And the points are parallel here and there, so the bend is for clearance. It does not matter in the geometry. Geometry goes from point to point. Doesn't matter what bend is in the link. This side is just going to get a lower link because the steering box lives here. And this plate sandwiches between the steering box bracket and the frame rail. And it houses our lower link. This one's going to be over slightly. And then we're going to make our plates that come from this main frame brace tube right here, come down, and then we'll have a spacer here. But as of now, our steering clears everything. We're at full bump. This link clears the cross member. This link will come up to here. I'm gonna have to recut and redesign my plates for my axle. I made these to bolt where the leaf springs did, but I was originally going with a rearward facing parallel 4-link, so I have to gotta redraw these and cut them. Just there's some extra material that doesn't need to be there, so those are gonna get redesigned. We're gonna move the shocks a little bit, and this is also gonna double as a bumper mount. All right, well, it is another day, several weeks later. You know how it goes with these projects. Life gets in the way. But anyway, I'm back out here in the shop today. It is going to be a hot one. It is already in the 90s here in Arizona. Can't believe it. Anyway, didn't get much of a break this year on the heat. But we're going to start cutting out all these files that Justin and I measured up, and he helped me draw up in the computer the last time we were working on this. So I've got my axle plates on the screen right now. We went ahead and he drew everything up together. I don't know how to do that yet. I usually draw one thing at a time. This is all new to me on this CAD design. It's something I'm learning as I go. I've only used this table a little bit. It's obviously well used, but I haven't done much with it. I got this thing used and have been gradually teaching myself how to draw in this software. And it's taken me some time, but it's good. I'm learning, and it's something I enjoy doing, is always learning new tools and trades and different ways of doing things. So today we're going to cut out the axle plates that bolt to the cast solid beam axle. Then we're going to cut out the bridge plates that index in these slots on here. You probably can't see this screen very well. You'll understand once I cut them out how this works. I'll show you, but everything is going to index together. So these plates are going to bolt where the leaf springs used to attach to the solid axle, and that is the original beam axle from the fleetvan. Why I'm doing this? I could get much better drivability and ride quality out of a Mustang 2 or a simple IFS setup, but I've done that already. I've done Mustang 2. I've done all the IFS setups. they're not different. They're just the same thing. This makes me stretch my brain. I've never done a 4-link on the front of a vehicle with the links facing forward. I don't know how it's going to act. I don't know how it's going to drive. I have done lots of 4-wheel drive 4-link stuff, but never a beam 2-wheel drive with the links facing forward. And I've never done a parallel 3-link before. So all this is new. I have not played with any of this in a geometry calculator because, let's face it, there's no room in this thing. So everything is going where it has to go to even fit. So I would do a rearward facing 4-link if I had the room. I just simply don't have the room. This thing is tight. Even with a 4-cylinder engine, there's not a lot of room. I could probably do some things, but I'm wanting this thing to sit real low when it's aired out. It's going to be on bags, like I said before. So I'm trying to get everything to fit and play happy together. And this is going to be a wild setup. I've never done like I said, a forward-facing link suspension. I've never done a parallel 3-link. And it's really cool how this is going to work. The steering, it's kind of like your typical 4-wheel drive crossover steering setup with a panhard bar, but the panhard bar and the steering are going to go through the middle of the 2 links on the one side. So going to be wild. So we've designed all this stuff, and Justin's a lot better at taking these ideas that I come up with and putting it into the computer. So he helped me with that. He's the one that's taught me all this stuff and gave me the basics so I can take it and run and learn. It's going to be years of learning. This software is designed to cut. It's okay. He has moved on to Fusion 360, which is all 3-dimensional stuff. He does 3D printing and does prototypes with that and gets them machined. The guy's a genius with that kind of stuff. It has a natural ability to teach himself stuff that is very complex. So anyway, it's been nice having him to help me along the way, learning some of this stuff. And by all means, this is very basic for CAD style designing, because we're just doing 2-dimensional and just simple plates with holes and stuff like that. Just getting them on the right plane and getting everything to line up is a bit of a trick, but we're working on it. Anyway, so we've broken these up into a couple of cut files. I'm going to cut these plates first, and then we'll do the bridge plates, and then I'll show you how they're going to work together, and we'll start putting this thing together. All right, so here we are, got our piece of 3/16 loaded up on the table. I'm going to go ahead and home our machine. This just basically, well, to tell you the truth, I don't really know what it does. I think it's just figuring out where the torch is in space. Now we got to set our start point, so we're going to manually run the machine to the approximate corner of the material. Set my start point. There we go. Okay, now what I'm going to do is what's called a dry run, and the reason I do this is just to see where it's going to be cutting. So if for some reason it goes off course or is halfway off of the material or something like that, I can catch it here without ruining some expensive plate. So we're going to do run. That's the outer perimeter of our part. You can see we're not going over the edges there, so we're good. It's going to cut the other plate. Going around the perimeter of the other one. All right. So it looks like we're good to go. So we're turning off the dry run. Now let's get to cutting this. It will get a little loud. Sorry, the compressor's going to kick on. I know I need to move it into a different part or outside or something so it's not annoying, but I'd like you guys to be able to see how this thing cuts. So here we go. There's our plate. Pretty cool. I realized I didn't have quite enough water in the table, so I topped that off. Now we're going to be cutting the upper bridge link mounts and the lower link mounts. So here we go with those. There you have it. There is one upper link mount for the 62 fleet van. You can see these tabs are going to actually interlock in my base plate. So this is the plate for to attach the 4-link to the axle. These will index right in here on the outside. So when I go to weld it, it holds it exactly where I want it. And you can see we have clearance for our U-bolts, or our bolts that bolt this to the U-bolt plate. And then you'll see these index on the outside of those slots. And then the other mounts on the lowers will index to the inside of this slot. And then when I burn it all in, it's all locked together and square. And so that's another big plus of this thing, is being able to cut slots for indexing parts. But yeah, it does a really nice job, cuts a nice plate piece. I'm sure I could do a better job by playing with settings and changing nozzles and different things like that. I'm sure there's a lot more to it that I don't know, but anyway. Now we've got our mounts, let's see how we can put this together. So you can see how this is coming together. This is the bridge that goes over the axle. The only thing I didn't take into consideration is this axle has a bit of a bump right here, so I got to do a little bit of clearancing. Need clearance on this lower piece, just to give me a little bit of room for this to drop down just a tiny bit more, and then that will fit perfect. And then here is, so this one you can see is different than this one. This one we incorporated a extra kick out that is going to be for my panhard bar that is going to run right through here. And this bracket you can see is hitting very badly on the U-bolts. We thought we had enough clearance for the U-bolts, but I can see where we messed up is we forgot to add in the extra 1/4 inch. Actually, you know what? I'm gonna flip those bolts over. That'll give me a lot more room. Put the bolt head on the top on this one. Let's see if that helps us out. Definitely give us quite a bit more room. Wanted this to be a very tight fit, and that it is. That's pretty much where they will be. Again, very tight fit. Got to do a little clearancing, and then we'll be good to go. But those look like they're going to fit great. Once they drop in where they're supposed to go, this gap will go away. I just need to clearance a tiny bit more right here for the bolt head on both sides. And then we'll have a perfect fit. So we've got our link tab in place for the upper link. And I always like to bolt in either a sleeve or an actual joint, so it holds everything square, especially with our indexing tabs. We know our bolt's gonna go through after I weld this. And right now I'm just gonna go ahead and tack this in place. If I open this up just a hair, I'll have enough room. This tab fits perfect. So we're gonna open this one up just a hair. A little dangleberry on it. Now those are perfect. Now let me get another bolt. You'll notice my plate is quite a bit bigger than where the link mounts are. Well, that's because I have to have it where the U-bolt plate is to bolt in. And then also I wanted to save some room to potentially add a shock mount for my air ride shock. Do a couple tack welds. Last but not least, I got to fit the other two to this side. So it's just a repeat of that process there. Any day now. Bringing it down. Should have made a monster truck out of this thing. Now with this setup, I am going to get quite a bit of caster change. The only beautiful thing is I'm only looking for minimal wheel travel. We're talking maybe 4 to 6 inches at most. So I'm not super concerned. That one is in there. Get in there. There we go. Now let's bring it on down to ride height. So here we are up under the van. You can see that I've got my 2 links in. This is on the passenger side. That upper link swings around the front frame cross member. And believe it or not, these are actually the exact same frame that's on a Willys military Jeep, like a World War II Jeep. Same thing as like a CJ3A, CJ2A. I believe it's the same as the civilian Jeeps, but they just added a chunk to the back of the frame. Wheelbase didn't change, just added a chunk to the back of the frame for the extra overhang of the body. But anyway, so I already see some things that I need to clearance. My plates for that bolt onto the axle are hitting on the back side of the frame, right behind my step notch. That is partly because I got to change my caster. My caster is way too far one way, so I'm going to have to adjust my link lengths a little bit. But this is just preliminary mock-up, proving a concept type thing. So here we are. Again, I don't have my stiffening, my boxing plate on the 2 link mounts. That's coming after, but let's jack it on up. And it does go up and down. There's way more down travel than we're ever going to utilize. All the way down to where we're making contact. This is actually going to be about ride height right here. And then once I clearance these plates, it'll go up further so we can tuck tire pretty far into the wheel well. But anyway, that's our front suspension mock-up. You can see the axle's already way up in there, tucked pretty high. I want to get these tires to where they're almost touching the inner fender well. I don't really want to cut the inner fender wells out, but we have clearance on steering, barely. I still have to create a track bar or panhard bar, whatever you want to call it. Same thing. You can see this plate right here. Still got to make a box end plate. Yes, sir. We have a a parallel 3-link front suspension on a fj3a fleet van. Definitely weird. Definitely goofy. Definitely a lot more work to come on this guy to make sure everything clears, everything is clearanced, and then we got to start building the panhard bar and then mounts for the Air Ride Technology shockwaves that I'm going to run. More to come. Those are not fixed. They have an adjustable end on both sides and a very, very long shank that goes clear up into these rods, so I can thread them out if I want quite a bit to adjust, and I can also bring the lowers in to increase caster. So just a couple turns on one way on the top and a couple turns on the other way on the bottom, and voila, you've gained your caster. I'm going to try to set it probably about 3.5, 4 degrees at ride height. And because of the short length of the links, we are going to get quite a bit of caster change throughout the cycle of the suspension, but like I said before, we're not going for 30 inches of wheel travel like a trophy truck. We're going for very low ride height, slammed on the ground. But anyway, these are our mounts. It's starting to look like something. As you can see, we've incorporated the bumper mount. I've got weld nuts inside there. The next thing that I'm going to do is build my plate. It's going to cap off the end here, bend, and it's going to grab both of these to make both of these mounts double shear and come back and weld into this factory cross member here. On this side, it's going to get a little tricky because I've got the steering box here, so I've got to make a different mount and space this over. It's going to be a little bit challenging. It's got to come out and kind of jog to grab this bolt and come around the steering box. And as long as I can still remove the steering box with these 3 bolts, this won't get in the way. It can't be in the way of the pitman arm, so I got to do a little bit of fine tuning. Pretty much this one will be, or this mount will be almost the same as this one, except because this tube kind of kicks up, the position of that's going to be a little different. So I got to make this mount and then come over here and start designing this to make all these 3 points double shear instead of single. But it is coming a long way. You can see how this bracket tucks in behind the steering box in between and boxes the frame in. We made it a little bit tall so I can weld right through here. And then also it will weld in here straight to the factory steering box mount. And we've got plenty of clearance in here for engine mount on this side, engine mount on this side. I do want to remake my engine mounts. These were just kind of temporarily to set the position of the engine. They're just some pieces of channel. I want to make something a little prettier than that. Or who knows, maybe I'll clean them up and stick with them. I'm not sure yet. But anyway, this is the progress. We're getting somewhere with the front suspension on this thing. And then later I'll go into what we're doing here. As you can see, probably caught this during this episode, but this side has a caliper bracket. This side still has a drum. So we are ditching the drum brakes on the front of this thing because this van is going to go far, far faster than it ever did from the factory. I'm using stock hubs, stock bearings, but instead of having a backing plate for a drum, making caliper brackets, and this is the same wheel bolt pattern as most Fords and Crown Victoria, believe it or not. For some reason, Jeep used 5 on 4.5 on these. Nothing else that Jeep did was 5 on 4.5. Most Jeeps in this era were 5 on 5.5, the bigger 5-bolt pattern. And then the Surrey and some of the smaller postal Jeeps were all 4-lug. So why the van got 5 on 4.5, no one will probably ever know. But I'll rebuild the hubs. Steering's still really tight, but I need to check all the tie rod ends. But our caliper brackets will bolt there, and then actually I can show it to you real quick. Just to show you guys, there's a Crown Victoria disc in place on this guy, and it clears everything. I've already had the caliper mocked up. This is going to work to give us large disc brakes in the front, way more stopping power than before. The rear is still drum. I am going to change that. Primarily, I think the drums would be fine, but I want something that's easier to get parts for. I'm going to keep the stock Dana rear end just because it's the right width. It's the right gear ratio for what I want to do with this thing. And later I can always put a Ford 8.8 or a 9-inch, or even I've used the Chevy Colorado rear ends quite a bit, but those are the wrong bolt patterns. So maybe I'll change out to one of the Ford rear ends. But anyway, thank you guys for sticking with me. Sorry this one is a little bit more tedious and slow moving, but hopefully by the next time that you see this, we will have a completed front end. I've got some more head scratching to do. I'll bring you guys along for the ride for that. And then next time, I'm gonna attack the back. I already have the notch done in the frame, and we're going to be doing, it's a lot more simple. It's a triangulated 4-link. I'm just using a kit from Airride Technologies on the back to button that up. So anyway, I appreciate you guys tuning in. I hopefully you didn't learn anything from me, because that would be bad. Again, don't do anything I do, but get out there and work on your projects. I need to work on mine more. But until next time, you guys all take care and have a great day.